We played with the yarn, and what we did, and I have it over here, is that we took our yarn, and the yarn was the length of the radius, and we went and we measured on the arc, on the outside of the circle, the length of the radius. Well, then this angle is called a radian. And we did our protractors, and then we did it exactly and said it was 57.3 degrees is equal to 1 radian. And so if a full circle is 2 pi radians, and remember we got 6 1/4, 6 and a little bit. So when it was supposed to come out to be 1 full rotation, 1 full revolution was 2 pi. And a semicircle is pi radians. Well, what I know is 2 pi radians equals 360 degrees. So if I divide by 2 to both sides, pi radians is 180 degrees. This is referred to as my conversion factor. So let's use our highlighters here. If I have degrees and I want to convert to radians, I'm going to multiply by pi radians over 180 degrees. The reason why is I want the degree units to cancel, and I want my answer to be in radians. Then, if I want to go from radians to degrees, I want the degrees in the top. So for me, it's not hard to remember. Whatever unit I want is in the top of the fraction. So watch this. And I'd like us to be able to do these without touching a calculator, but that might be a little too optimistic. But let's give it a whirl. It says I want to convert the degrees to radians and any radians into degrees. So if I have pi over 2, that's radians, right? And so I mentioned this early on, and you may not have picked up on it. I said it's critical that you include a degree symbol, because if you don't have a degree symbol, it's assumed radians. So pi over 2 is then assumed radians. So I want this in degrees, so I'm going to multiply by 180 degrees over pi. Then watch what you do. I can cancel the pi's, and I get 180 degrees over 2, and we can do that in our heads, right? What would 180 divided by 2 be? 90 degrees. So pi over 2 radians is equal to 90 degrees. And doesn't that make sense? If you take pi, which is 180, and divide by 2, that's up here at a 90-degree angle. All right, let's try the next one. If I have 225 degrees, then I'm trying to go to radians. You don't need to write out pi radians, okay? It's assumed you're radians. Okay, now something I need to remind you of when you're doing these. I'm going to try my best to keep these on our unit circle, which are 30, 45, or 60 degrees, and then any of their multiples. Well, 225, it can't be a 30 or a 60, right? So it's probably going to be 45. So let's stop and try that. How many 45s are inside 180? Without touching a calculator, I want us to really use our brains. 4, right? Okay, I saw some good hand motions there. Look, 45 and 45 is 90. So then I have 180. So down here, 45 went in there 4 times. Then if I added another 45, what's 180 plus 45? 225, so isn't that 5 times then? And do you notice we never touched a calculator? Let me go over that one more time. 45 and 45 is 90. 90 plus 90 is 180. So that's where 45 goes into 180 4 times. Then when you look at 225, let's not be intimidated. Let's not be scared of that. If I take 180 and add 45, that just meant there was one more 45 in there. So my final answer is 5 pi over 4. Okay? And again, I want us to really practice not using a calculator and really working on exercising our brains. So if I have negative 210 degrees and I want to put it in radians, what's the conversion fraction? Which way do I write it? Pi over 180. So now something I want to remind you of is, because I'm going to keep these into the unit circle. Now they could be 90s, okay? So 210 and 180. Do you remember back from elementary school that when you were first learning, if two numbers end in a 0, then 10 goes into both the numbers, right? Let me repeat that. If two numbers end in a 0, that means 10 was going into both numbers. Now I can make this, it's not so scary, okay? It's not so scary. Then 21 and 18, what is the biggest number that goes into both of those? 3, right? Okay. So 3 goes into 21 7 times, and 3 goes into 18 how many times? 6. All right. This is not too bad. Negative 3 pi over 4. What's the fraction I'm going to multiply by that will convert it from radians to degrees? 180 over pi. So the first thing I'm going to do is I'm going to cross out the pi's. And then I need to tell you something that's going to happen often. You're going to frequently do 4 into 180. Okay, that's going to be a common one that hopefully you'll just start to remember it. 4 goes into 180 how many times? 45, right? 45 and 45 is 90. And I have 2 sets of those. So that's going to cancel down to 45 degrees. And then guess what? It will not kill you to off to the side take 45 times 3, or add them up in your head. So go ahead and do that. Don't touch a calculator. Really want us to practice this. Yeah. Yeah, I just decided to cancel the zeros first, but you could do 30s because that is the greatest common factor. All right, anybody get it yet? Was it negative 135? And don't forget the degree symbol, because I will ding you maybe just half a point. But if you don't put a degree symbol, it is assumed radians. All right, so one more time. This is very, very simple. If I want to convert from degrees to radians, I multiply by pi over 180. If I want to go from radians to degrees, I multiply by 180 over pi. All I think, and this will help you in whatever science classes you're in, when you're like, okay, I don't know where to do the fraction, just think about what unit do you want, and you're trying to cancel to get that unit up in the top of your fraction. All right, then our last topic. This is a very, very short section. I chunked this. We're going to spend 2 days on this. And then Thursday we're going to review. Friday we're going to have a 7-2, 7-3 quiz. So if I take a full rotation, this is called 1 revolution. So 1 revolution equals 360 degrees, or 1 revolution, if I'm in radians, is equal to 2 pi radians. So go ahead and jot that down. Yes. I just finished it, so I'll try to post it definitely by tomorrow if you want to work ahead. But yeah, you're welcome. All right, so now let's look at these last 3. It says, what fraction of a revolution is the angle 30 degrees? So watch what you're going to do. And again, it's just a lot of common sense. I'm in degrees, so my conversion fraction is going to look like this. I want to know how many revolutions, so I want my units to be revolutions. I was given degrees, so it's going to be 1 revolution over 360 degrees. the revolutions cancel. What did I just say? I said the wrong. The degrees cancel. Like, I do that all the time. I'll say to my kids, go in the dining room and pick up da-da-da. And they're like, it's not in the dining room. I'm like, why are you in the dining room? I meant living room. Your parents do that? That's sad. It happens. It happens to us. Okay. So now I want to ask myself, 30 and 360 have 30 is the greatest common factor. So 30 goes into 30 once. 30 goes into 360 how many times? 12, right? 12. So this is 1/12 of a revolution. Oh, that makes sense, right? 30 degrees, it's teeny tiny. Because 90, okay, let's try to make a nice visual connection here. If I were 90 degrees, what part of a revolution is 90 degrees? 1/4, right? How many 30s are in 90? 3 times 4 is 12. Oh, pretty cool. All right, what is the degree measure of 1/8 of a clockwise revolution? What's clockwise mean? Negative. Okay, so 1/8 clockwise, that's a revolution. I want to know the degrees, so my conversion is going to be 360 over 1 revolution. So pay attention to the manner in which you're rotating, because clockwise is a negative angle of rotation. So I'm going to cancel out my revolutions. All right, watch this. This is really, it's good for your brain to not touch a calculator. Watch this. 360 divided by 8. 8 goes into 360 4 times. That's 32. 4, bring down the 0. 8 goes into 40 how many times? 5. So this is a negative 45-degree rotation. So I asked for the revolution, I asked for the degrees, now I'm going to ask for the radians. It says if we have 3 revolutions, and again, don't touch a calculator, if we have 3 revolutions, how many radians do we have? So can anybody give me help? Yeah, Sydney, what do you think we're going to do? You got it, okay? I start with 3 revolutions, so I need to cancel the revolutions. So I'm going to cross those out, and I'm just going to get 6 pi. You can write radians or not write radians. It will be implied that those are, in fact, radians. That is it. So go ahead and pull up your notes. Or not your notes. Gee whiz, I'm having a rotten day here with my words. Pull up